Gennem 160 millioner år dominerede dinosaurerne jorden. De mest succesrige landdyr nogensinde. Og så, på et øjeblik i geologisk tid for 65 millioner år siden, forsvandt de. Det er en af naturvidenskabens store gåder. Hvad skete der? Var det skæbnesvangre ændringer i jordens klima? En pludselig stigning i den vulkanske aktivitet? Sygdomme? Eller noget helt andet? For over 200 år siden fastslog Jean Cuvier, at fænomenet uddøen var en kendsgerning. Mastodonter og andre dyr, man havde fundet levn af, som sabelkatten, var uddøde, hævdede han. Og denne erkendelse banede vej for studiet af endnu tidligere planter og dyr. Fossile rester viser, at blandt nogle dyreslægter uddør der gennemsnitligt en art hver 5 millioner år. Men fra tid til anden synes der at være forekommet en mere omfattende uddøen, hvor mange planter og dyregrupper næsten samtidig er blevet kraftigt beskåret. En ved slutningen af Trias-tiden, en anden ved slutningen af Jura, som hver især åbnede muligheder for nye former af dinosaurer. Og så ved kridttidens slutning skete en sidste uddøen, der afsluttede dinosaurernes herredømme for altid.
These mass extinctions are very special and very terrible events.
Palæontologen Robert Barker.
It's not just one species going extinct, that happens all the time. But usually you lose a species, a new one evolves, the whole family of species keeps on going. But right now with the great cats, most of the big species are extinct. We're not getting any new ones, and pretty soon all of the great cat family is gone. That's what hit the dinosaurs. The families of dinosaur species died out, no new species were formed, and they were gone. It was a horrendous geological crime. Who is exterminating the great species again and again and again? Let's look at some of the potential criminals.
Et godt bud er miljøet. En forandring i jordens klima. På dinosaurernes tid var klimaet generelt varmere end i dag. Hvis temperaturen steg eller faldt drastisk, ville plantelivet visne, og først planteæderne, og derpå de store rovdyr, ville uddø. Klimaforandringer kunne skyldes ændringer i solens indstråling eller forskydninger i kontinenternes beliggenhed og dermed anderledes havstrømme, vinde og nedbør. Og dinosaurerne, der så vidt vides ikke var udstyret med fjer eller pels, kunne ikke opretholde den nødvendige kropstemperatur. Ej heller kunne deres æg udruges. Eller måske uddøde dinosaurerne, fordi en kolossal kraftig vulkansk aktivitet spydede giftige luftarter og aske ud i atmosfæren og blokerede solens stråler. Der findes meget store lavadækker, tilsyneladende dannet samtidig med, at de sidste dinosaurer forsvandt.
Or maybe the newest and sexiest theory has the answer. Maybe something out there from the cosmos smacked into the Earth, sending up a plume of dust, blotting out the sun's heat, and freezing the dinosaurs to death. Something huge, something full of energy, an asteroid.
Ideen om, at det var et asteroidenedslag, der udslettede dinosaurerne, blev introduceret i 1980 af et hold forskere ved Berkeley-universitetet, ledet af geologen Walter Alvarez.
Back in the 1970s, I was working in Italy with a group of other geologists and geophysicists on a project that had nothing to do with the dinosaurs. We were measuring, we were dating the reversals of the Earth's magnetic field that were recorded in a series of rocks that had been deposited on the floor of the ocean, one after the other like this, sort of made a book of Earth history. And while we were doing that work, we kept walking past this very intriguing layer of clay, and so I cut out a piece and brought it home. You can really see what's going on here. This layer is the top bed of the Cretaceous. This corresponds in time to the last times that the dinosaurs were alive. And this bed up in here is the first bed of the Tertiary, which is after the dinosaur extinction was over. And in between them is this layer of sort of red and green clay. And it seemed as if that had to be telling us something. So I cut out this piece of rock and brought it home, and not only was it interesting to me, I showed it to my father. It was interesting to him, too, and we decided, let's see if we can find out what is responsible for that clay.
Walter Alvarez' far, Nobelpristager i fysik, Louis Alvarez, begyndte forsøgsvis at datere lerlaget for at bestemme, hvor længe det havde været om at aflejre os. Hans resultater lagde grunden til nedslagsteorien. Leret viste sig at indeholde usædvanligt store mængder af ædelmetallet iridium, der minder om platin. Alvarez vidste, at iridium kun sjældent forekommer på jorden, men er almindeligt i asteroider og kometer. Han tog det som tegn på, at en kæmpemæssig asteroide var kollideret med jorden.
What we finally came up with was the idea that dust and droplets of impact melt that had been thrown out of the atmosphere and dispersed all over the planet would make it so dark that photosynthesis would stop and the food chains would collapse and the extinctions would be the result of starvation when the food supply ran out.
Ifølge Alvarez-gruppen begyndte en stor støvsky umiddelbart efter nedslaget at indhylde jordkloden. Under det tætte støvlag blev dag forvandlet til ubrudt nat. Fødekilderne udtømtes. Dinosaurer og millioner af andre dyr gik til grunde i kulden og mørket.
So what does it all mean? What does it tell us? It really tells us that there was a little more to evolution than Darwin realized. Darwin had it right, but he didn't have the whole story. Darwin said that in order for a species to survive and flourish and produce descendants, it had to be well adapted. It had to be very good at making a living in the normal world that it lived in. And what we're finding out now is, yes, that's true. That's absolutely true. But in addition, there's an occasional really bad day when a huge rock falls out of the sky and makes terrible environmental disturbances.
Forestillingen om, at dinosaurerne blev ofre for et nedslag fra rummet. Men er den sand? Vi befinder os i Makoshika-naturparken i det sydlige Montana i USA. Formationerne her rummer vidnesbyrd om jorden, som den var umiddelbart før dinosaurerne forsvandt.
We're going to line you up on the outcrops to do the survey. And you'll be about 10 or 15 feet apart, and you're going to walk slowly over the outcrops, looking for fossils. When you find...
Diane Gabriel og David Vastovsky har hentet et hold studerende til Makoshika for at tælle knogler. Med deres hjælp håber de at kunne besvare et omstridt spørgsmål. Var dinosaurernes undergang pludselig, som nedslagshypotesen indebærer, eller uddøde de gradvist i løbet af adskillige millioner år?
So let's walk over that way.
Spørgsmålet er aldrig blevet besvaret entydigt. Blandt andet fordi antallet af dinosaurer på et givet tidspunkt aldrig har kunnet beregnes. Vastovsky og Gabriel besluttede at tælle hver eneste knogle i dette område.
Okay, everyone in position. Let's go. Remember to stay in line as much as possible.
De valgte dette sted, fordi jorden her er fyldt med knogler fra slutningen af dinosaurernes herredømme. De sidste 3 millioner år af den periode i jordens historie, der kaldes kridttiden. Grænsen mellem kridttiden og den efterfølgende tertiærtid ses her som et blåt bånd, der løber mellem formationerne. Over grænsen er der ikke fundet rester af dinosaurer. Men under den er de overalt. Det kræver blot tålmodighed og et skarpt øje. For de halvt skjulte knogler skildrer sjældent med deres tilstedeværelse.
Bone! We have bone, yes!
Okay. We'll be right there. On our way, Jackie.
Oh, it looks like a claw.
Oh, wow.
That's nice.
Wow. Oh, really nice.
Yeah, it looks like an ornithomimid to me. One of those ostrich-like dinosaurs?
Oh, yeah.
Yeah.
What'd you find?
We found an ornithomimid claw.
Well, that's terrific.
Real nice.
Well, what do you think?
Hvert fund bliver omhyggeligt registreret. Kategori, position og bjergarten stykket lå indlejret i.
Yeah, medium grain cross-stratified.
Gennem de sidste 3 år har Vastovsky og Gabriel og deres kolleger talt knogler i den mest udførlige fossiloptælling, der nogensinde er foretaget. De har registreret 4.600 stykker fra mere end 600 lokaliteter. Deres materiale tyder på, at dinosaurerne klarede sig fint helt frem til slutningen af kridttiden.
The predominant animal that we found in our survey was Triceratops. The ceratopsians are really abundant at the end of the Cretaceous. And the next one would be the duck-billed dinosaurs, probably Edmontosaurus. And we found a lot of ornithomimids and animals like that. But we've also found lots of the small carnivores, the ones that scavenge and pick up after the other ones have killed them. And we do have Tyrannosaurus rex, too.
There doesn't seem to be any evidence for a gradual decline in their diversity. In fact, our study shows that in geological terms, their extinction was instantaneous.
I dinosaursammenhæng er tidsskalaen overvældende. Her betyder øjeblikkelig 250.000 år. Der kræves flere belæg til at underbygge hypotesen om et asteroidenedslag. For eksempel, hvor stor sandsynligheden overhovedet er for, at det kan ske. En gang om måneden, de få dage, hvor der er nymåne, tager Gene og Caroline Schumacher ud til Mount Palomar-observatoriet for at undersøge dette spørgsmål. Ægteparret er førende inden for en relativt ny gren af astronomien. En, de praktisk talt selv har opfundet. Asteroidejagt.
When we started our program here in 1973, there were a dozen known Earth-crossing asteroids. They'd all been found accidentally over the course of some decades. And we began a systematic search then to look for more of them. At the present time, we know over 110 Earth-crossing asteroids have been sighted.
At udpege asteroider er et langsommeligt arbejde. Teleskopet svinges i stilling til at affotografere et nøje udvalgt område af nathimlen. Hver optagelse kræver adskillige minutters total koncentration.
10, 11, 12, 13, 14, open. On 34 minutes, 15 seconds.
Et nyt foto bliver taget flere timer senere, og derpå sammenholdt med det første. Resultatet? Et spøgelsesagtigt spor af en asteroide på vej mellem stjernerne. Denne asteroide blev opdaget af ægteparret Shoemaker i marts 1989. Den passerede jorden inden for en afstand af 1 million kilometer. Mindre end 2 gange afstanden til månen. Tæt på og slet ikke usædvanligt. Ægteparret Shoemaker anslår, at der er omkring 1500 asteroider med en diameter på over 1 kilometer, hvis baner skærer jordens. Men Gene Shoemaker tror, der skulle noget større end en asteroide til for at forvolde ødelæggelserne for 65 millioner år siden.
The objects that make really big craters, 100 kilometer diameter craters or 150 kilometer diameter craters, that would produce a global catastrophe from the material that would be ejected and carried all around the Earth. Those objects are probably chiefly comets. My best estimate is that an object big enough to make a 150 kilometer crater, which would be about a 10 kilometer diameter comet, about the size of Halley's Comet, hits the Earth about once every 100 million years on the average.
Asteroide eller komet. Hvis en kæmpemæssig stenblok faldt ned fra himlen, måtte det have fået skæbnesvangre konsekvenser for mange andre end dinosaurerne. Her i Sumaya i Spanien er der mere materiale at tage stilling til. En gruppe havdyr, helt ubeslægtet med dinosaurerne, forsvinder ud af fossilrækken på nøjagtigt samme tidspunkt som disse. Palæontologen Peter Ward fra Washingtons Universitet i Seattle er kommet til Sumaya for at forestå en optælling af samme slags, som Pastovsky og Gabriel gennemførte med dinosaurerne. Det, der interesserer ham, er disse engang så talrige havdyr, ammonitterne.
This is an ammonite fossil from these cliffs. If we could go back through time and find one of these alive, we would see that it's a swimming creature. Out of the front sat a series of tentacles, and much like the chambered nautilus does in today's oceans, it could swim around. During the Mesozoic, these creatures were fantastically abundant. There were 12,000 species of them, and although this is a small one, the largest of them were about 12 feet across. That would probably do you great damage were it to come up to you. These creatures are so abundant in the Cretaceous seas that were we to go back there, we would find that they occupied much of the place that fish do today. These are really the fish of the Cretaceous oceans.
Her i Sumaya er grænsen mellem kridt- og tertiærtiden skjult i en hulning, der løber under en udhængende klippe. Indtil for nylig mente Peter Ward, at ammonitterne uddøde længe før kridttidens slutning. Hans nyeste undersøgelser viser noget andet.
The gully I'm sitting next to is composed of a clay layer, which is the boundary between the Cretaceous period and the Tertiary period. The rocks I'm sitting on are Cretaceous rocks. The limestones over my head are the first Tertiary rocks. Ammonites can be found in relatively common numbers within these rocks, and the last of them are found within inches of the boundary. It seems that the ammonites at the end of the Cretaceous were thriving. They were producing new species, they were flourishing in their communities, and then suddenly, without warning, they disappeared.
Da dinosaurerne forsvandt fra landjorden, overgik en tilsvarende katastrofe dyrelivet i havet. Sammen med ammonitterne forsvandt hele grupper af små og store havdyr. Men kunne en asteroide afstedkomme en så verdensomspændende ødelæggelse? Dette er Meteor Crater i Arizona i USA. Det cirka 1,5 kilometer store krater er resultatet af et nedslag af en meteor på blot en 50 meter i diameter. Skal Alvarez-hypotesen holde stik, må himmellegemet, der udslettede dinosaurerne, have været 220 gange større. Hvis vi antager, at det faktisk var tilfældet, hvordan ville virkningen så have været? Teoretikeren Jamie Lash beskæftiger sig med, hvad der sker, når kæmpemæssige klippeblokke falder ned fra himlen.
This is Kitt Peak National Observatory in Arizona, and I brought you here to give you a feeling for what the impact of a 6-mile diameter asteroid will do to the Earth. To get an idea of what 6 miles diameter really means, imagine the space between here and that distant peak on the horizon to be completely filled up with rock material. And further, imagine the space between the valley floor below us and an altitude of 6 miles filled up with solid rock. This enormous ball of rock will be rushing toward the Earth at 50,000 miles an hour, a speed that, if you were riding it, would take you from here to New York in under 3 minutes. When the asteroid strikes the ground, it buries itself in the Earth in a period of only 1 second. It opens a crater, a hemispherical hole in the ground that reaches a diameter of 30 miles about 10 seconds after the impact occurs. At that time, it's 15 miles deep. It's lined with red-hot rock debris streaming outward, forming a plume heading into the sky. At that time, the crater floor begins to rise back up. At the same time, the diameter of the crater continues to increase. It goes on until it reaches a diameter of about 100 miles before it stops growing. What happens next is really interesting. As the asteroid plunges into the ground, it creates pressures about equal to that of the Earth's core. Under those pressures, the asteroid and also some of the Earth rock melt and vaporize and expand back out of the crater as a plume or glowing cloud of very high velocity gas and dust. This cloud expands at velocities up to the Earth's escape velocity, sending the debris into ballistic orbits that eventually rain back all over the Earth. Trillions of tiny particles of this kind would fill the sky, radiating heat toward the ground. On the ground, you would feel an effect very similar to that of an oven on broil, lasting for about an hour. The Even green vegetation would dry out and begin to burst into flames spontaneously as a result of this thermal radiation, causing global forest fires.
Der findes tegn på, at dette måske fandt sted. Millioner af mikroskopiske kulpartikler er blevet fundet i det ler, der blev aflejret ved slutningen af krigstiden. De kan tolkes som sod fra kolossale brande. Men blandt andre danskeren Hans Jørgen Hansen er overbevist om, at der er tale om partikler fra vulkanske udbrud, og lerlaget rummer flere overraskelser. Ved USA's geologiske undersøgelse i Denver benytter Glenn Isaac og hans kollega Fred Litke en laserkanon til at analysere grænselaget mellem kridt- og tertiærtiden. Laserstrålen rammer prøven med millimeters nøjagtighed og omdanner den ramte partikel til gasform.
So the white spectra here is the Cretaceous marl.
That's right.
And that's superposed with the blue spectra here, which is the overlying impact layer. So where's the iridium, Fred?
Okay, the iridium. Let me show you here.
Iridium, der sjældent forekommer på jorden, men er almindeligt i asteroider, rammes under analysen. I denne prøve fra Colorado repræsenteres metallet af den højeste af de blå spidser, og prøven er typisk for hundreder af andre fra netop dette lag fundet rundt omkring i verden.
We have two isotopes approximately in the right order for their natural abundance.
Isaac har påvist, at leret også indeholder usædvanlige og, siger han, bemærkelsesværdige kvartskorn. Set i polariseret lys fremtræder kvarts normalt ensartet og strukturløst. Dette er kvarts fra grænselaget.
It shows these very peculiar lines through the quartz grain. They're oriented in this particular grain in this direction and this direction. These are called shock lamellae, and the only place that these have been found in rocks of the Earth's crust happen to be at high-yield nuclear explosion sites or at known meteor impact sites.
Iridium, kulpartikler, trykpåvirket kvarts. Alt dette kunne pege mod et asteroidenedslag i slutningen af krigstiden. Men hvis en asteroide faktisk ramte jorden, hvor er så krateret? Det skulle i så fald være mange gange større end det i Arizona. Glenn Penfield er geofysiker tilknyttet olieindustrien. I 1978 arbejdede han på Yucatán-halvøen i Mexico. Hans opgave var at finde olieforekomster for Pemex, det statslige mexikanske olieselskab. På en række sonderinger fra luften målte han svage udsving i jordens magnetfelter. Med lidt held på disse udsving afslører olielommer i undergrunden. Arbejdet forløb planmæssigt. Men efterhånden som undersøgelserne skred frem, begyndte der at tegne sig et overraskende billede.
From the beginning, when we first collected data from the aircraft, I began noticing a pattern of extraordinary symmetry in the magnetic anomalies. Later we put these into a map, and the picture held up. One of a zone of highly magnetic material, an enormous ring of very intense magnetic anomalies that you can see here on the map, about 70 kilometers across. Very, very strong gradients in the field. Further out, a ring of very subtle features with a diameter of about 210 kilometers. A similar sort of configuration of anomalies is visible in the gravitational data. We see a central ring of high gravity anomalies indicating more dense material here in the center, again about 65 kilometers across, then a gravity low indicating lower density material, and finally another gravity high 180 kilometers in diameter. This area had been interpreted as containing volcanic features, but I had never seen volcanic features with this kind of symmetry on this sort of scale before. And it appeared to me that this had to be the result of a single event that at one time froze both the gravity and the magnetic fields in this highly symmetrical, highly ordered arrangement. And the most likely explanation to me was that of a gigantic meteor impact.
Der var ingen tvivl om, at Penfield havde opdaget noget. En stor ringformet struktur, godt 200 km i diameter, 800-900 meter under Yucatans overflade. For sit indre øje så Penfield et meteorkrater, komplet med en hævet midte og koncentriske ringe. Men hvor var de fysiske vidnesbyrd i form af bjergarter, der var præg af nedslaget?
We lacked any samples to prove it. We had these excellent geophysical data sets, the magnetic and the gravity data, but not the physical samples which could establish once and for all that this was a gigantic impact feature.
I 1950'erne havde olieselskabet foretaget prøveboringer 2 steder på Yucatan. Begge steder var der blevet taget prøver af undergrunden, men da Penfield bad om at måtte se dem, fik han at vide, at de alle var gået tabt. Penfield nægtede at give op og tog i 1982 til Yucatan for selv at se, om der skulle være efterladt nogle prøver ved borestederne. Først ledte han i den lille landsby Zacatepec.
This is the Zacatepec #1 wellhead here in the middle of the village of Zacatepec. It was actually pretty easy to find. There were a lot more pigs when I was here a decade ago, and I dug both here and in the mud pit from the well that was drilled here, digging through quite a bit of pig manure that had been left for the last 30 years, in order to find the samples that might prove that this was an impact feature. This well was drilled to 1,500 meters, and for the first 1,000 meters it was just a monotonous sequence of white limestone rock. And then the well site geologist reported a broken up kind of greenish material for a substantial thickness, and then finally something that looked like glass. Appeared to be a volcanic sort of glass, is the way it was described. And it was for a sample of either one of those two rocks, either this broken up greenish material or the glass, that I had come here.
Zacatepec-borestedet gav ingen resultater, så Penfield fortsatte til nabobyen Chicxulub. Her, på en forladt landejendoms jord, fandt han det andet borehul.
Chicxulub #1. Total depth 1,581 meters, 620.52. The final result of all my searching at Zacatepec and Chicxulub really amounted to very little. Oh. I had a few samples of cement matrix with some shards of rock in it that may or may not have come out of the wells. They weren't really amenable to any kind of analysis that would show that Chicxulub was an impact feature. And so, for the time being, I was completely stuck.
Penfields anstrengelser havde ikke båret frugt. Han sammenskrev sine tanker og erfaringer og vendte tilbage til oliesøgningen. I mellemtiden havde Walter og Luis Alvarez fremsat deres asteroideteori. Nu ledte alle efter krateret. Dog ikke i Mexico. Dette er Brazos-floden i Texas. I 1987 havde Alan Hildebrand, dengang studerende ved Arizonas Universitet i Tucson, hørt om nedslagsteorien og var gået i gang med at lede efter spor af et sandsynligt krater. På det tidspunkt havde han aldrig hørt om Glen Penfield.
Today, the Brazos River here is about 200 miles from the Gulf Coast. 65 million years ago, the late Cretaceous sea covered this area. Here was about 500 feet deep. Along the banks of this river, we see the fossils of ammonites and other marine creatures that lived along with the dinosaurs and went extinct along with the dinosaurs at the end of the Cretaceous.
Hildebrand vidste, at flodbrinkerne gemmer på en krit-tertiærtidsgrænse, der ikke ligner nogen anden, man kender i verden. De fleste steder er krit- og tertiærlagene adskilt af et lerlag på højst godt 1 centimeters tykkelse. Men i skrænterne her er der et næsten 1 meter tykt lag af uregelmæssige fragmenter. Her er skellet mellem dinosaurernes verden og eftertiden forbløffende tydeligt.
This outcrop shows the Cretaceous-Tertiary boundary section. My feet are resting on the Cretaceous sediments. This is mud that was deposited in a sea that was about 500 feet deep. Here's the base of the Tertiary. From here upwards, we have sediments that represent a time when the dinosaurs were extinct. There's about 3 feet of sediment in between that indicates something extraordinary happened here. In particular, this lump of gray clay, which is a bit indistinct. You see it goes around like so. This is a boulder about 3 feet across. Something happened that was able to uproot this gray clay from the Cretaceous seafloor and transport it and dump it here. Similar deposits of rubble like this occur all along the southern coast of North America at the Cretaceous-Tertiary boundary. The presence of the rubble beds here and the rubble beds all along the southern coast of North America indicates that something extraordinary happened here, something like a giant wave washing across the southern margin of the continent. We can't imagine how such a giant wave could have formed except for something like an impact in the ocean.
Stadig uden kendskab til Penfields undersøgelse på Yucatan-halvøen, antog Hildebrand først en ringformet struktur på havbunden ud for Colombias kyst for at være krateret. Han ledte efter arret på jordens overflade efter et meteoritnedslag. Så hørte han om en anden lokalitet. Denne gang på Haiti. For 65 millioner år siden var området her, ligesom det omkring Brazos-floden i Texas, dækket af hav. Højt oppe i bjergene, nær landsbyen Baloc på Haitis sydlige halvø, var der en særpræget formation af havaflejringer. Den blev opdaget af haitianeren Florentin Morasse, der nu er tilknyttet Floridas Internationale Universitet i Miami.
This is my site. That's the Baloc Formation. The bottom 2/3 from the valley is Cretaceous, and above it, that's Tertiary. Right about 1/3 from the road, you can see a little quarry, and that's where we have the KT boundary.
KT-grænsen er betegnelsen for det lag, der blev aflejret ved kridttidens slutning og tertiærtidens begyndelse. Moraes mente at have fundet aflejringer fra en fortidig vulkansk aktivitet. Der skulle gå 15 år, før Alan Hildebrand foreslog, at laget, som i Brazos-flodens brinker, kunne markere tilstedeværelsen af et nærliggende nedslagskrater.
Okay, this is another piece of the boundary layer. As you can see here, it is very, very distinct. At the bottom, that's Cretaceous, and here that's the boundary, the so-called boundary layer. And we are going to take a sample to show you what it looks like.
Det var på dette tidspunkt i september 1990, at denne serie kom til at spille en lille rolle i historien. Prøver, der blev indsamlet til brug for serien, viste sig af særlig interesse for både morasse og AZ.
Here's a sample of the rock that you see here being collected by Florentine Morass, and that the dinosaur production team was kind enough to bring back from Haiti. I've mounted the rock sample in plastic and then ground it flat so we can see what's going on with this rock. What really drew my attention is this zone here in the base of the sample, about 2 centimeters thick, of greenish black pellets.
Set under mikroskop havde smålamerne en karakteristisk form. De lignede tektitter, dråber af smeltet materiale sprøjtet ud af jorden ved et kraftigt nedslag og derpå størknet. En dråbe mælk, der falder ned i en skål, skaber de samme former, i det den rammer ned i væsken. Tektitter i grænselaget ville underbygge, at et asteroidenedslag fandt sted ved kridttidens slutning. AZ kiggede nærmere på smålamernes indre.
It turns out to be a black glass, real tektite glass. It demonstrates that there really was an impact at the Cretaceous Tertiary boundary. Tektites have only been found associated with large asteroid or comet impacts.
Samtidig var Alan Hildebrand stadig i færd med at gennemstøve den videnskabelige litteratur på jagt efter omtale af de ringformede strukturer, der kunne vise, at et nedslag havde fundet sted. Omsider stødte han på Penfields artikel om Yucatan-krateret. I artiklen omtalte Penfield de forsvundne boreprøver. Men kunne de opspores? Hildebrand gik videre med sagen.
I wrote people, I called people, I talked to dozens of different people, and finally, with the help of colleagues, we got lucky, and I found that a set of samples have been sitting in New Orleans for the last 20 years.
I april 1990 videregav Hildebrand oplysningerne til Glenn Penfield, og Penfield aflagde besøg på geologisk afdeling af Universitetet i New Orleans. Efter 12 år var hans søgen næsten slut.
This is typical of the limestone rock present in the Yucatan number 2 well.
Hullet, der var blevet boret i Chicxulub. Der blev optaget utallige kerneprøver, mens boret gnavede sig ned gennem 3 kilometer jordskorpe. De så alle sammen relativt ens ud, undtagen en.
This one here, from 301 to 303 meters, is unlike any of the others. Green, full of fragmented shards of broken up rocks that existed previously. It has a texture totally unlike any of the other samples of the limestone throughout the well. And it signifies a rock put together of fragments of pre-existing rock, disordered and jumbled together and broken up.
Penfield sendte en prøve til Alan Hildebrand for at få undersøgt, om den indeholdt spor af et komet- eller asteroidenedslag, iridium eller trykpåvirket kvarts.
When Glenn Penfield sent me the first samples we'd found in New Orleans, we did a couple of separations of them, and we found some shock quartz in both of the samples. And of course, with the duplication and the care we take in making these preparations, we were quite sure that we'd established that shock quartz occurred in this deposit outside but near the crater. So likely the big hole nearby was a crater.
For millioner af år siden skete der noget her. En gigantisk eksplosion, der sendte chokbølger hundreder af kilometer i alle retninger og førte materiale med sig, så langt som til kysten af Texas.
We're sitting here at ground zero in the Chicxulub crater. It stretches for 90 kilometers in every direction around us and represents one of the most cataclysmatic events in the Earth's history. We named it Chicxulub, both for the village nearby here and for the first well that was drilled into the structure, but also appropriately because Chicxulub in the ancient Mayan dialect means the tail of the devil.
Yucatan-krateret har den rette placering og den rette størrelse. Men er det rette svar? Måske var dinosaurerne allerede ved at uddø. Forskerne ved, at der levede 61 slægter af dinosaurer 6 millioner år før kridttidens slutning. Men 2 millioner år før kridttidens slutning var tallet reduceret til 18. Der er nu disse belæg for, at noget faktisk ramte jorden i sen kridttid. Alligevel væger de fleste paleontologer sig ved at godtage, at denne hændelse kunne have udryddet dinosaurerne.
Okay, the asteroid theory. Does it explain the extinction of dinosaurs? There are problems. There is the frog problem. You see, there are thousands of species of tropical frog today, and frogs are immortal as family of species. They never suffer mass extinction. When the mammoths went extinct, the frogs survived. When the dinosaurs went extinct, the frogs survived. And frogs are very delicate animals, very delicate to climate change. If you smacked the Earth today with an asteroid, blotted out the sun, you would freeze frogs long before you'd freeze a big animal. What kills off big animals like dinosaurs or elephants? What does an elephant do that a frog doesn't? Elephants spread.
Robert Barker påpeger, at store landdyr, såsom elefanter, tilbagelægger kolossale afstande i løbet af deres liv. I den forstand ligner dinosaurerne nutidens aktivt vandrende dyr, der er i stand til at færdes over vidtstrakte områder. Og mod slutningen af kridttiden synes dinosaurerne at være brudt op og har begivet sig på vandring. Nydannede landbroer forbandt tidligere adskilte kontinenter og gjorde det muligt for dinosaurer at sprede sig i et omfang uden fortilfælde. Dette bragte forskellige arter af dinosaurer i berøring med hinanden for første gang, hvilket fører til Robert Barkers foretrukne teori om dinosaurernes uddøen. Barker påpeger, at sidst i 1800-tallet spredtes sygdommen kvægpest fra Asien til Afrika og truede med at udrydde næsten 40 arter af afrikanske antiloper. På samme måde, hævder han, blev dinosaurerne, da de krydsede landbroer, udsat for nye typer sygdomme, der kunne have tyndet kraftigt ud i bestandene. Ligesom de kolonister, der bragte mæslinger til den nye verden, spredte de vandrende dinosaurer sygdom og blev ofre for deres egen voksende udbredelse. Hvad forårsagede dinosaurernes undergang? Ingen ved det med sikkerhed. Der er ingen enighed om et mest sandsynligt svar. Men det vi ved, som resultat af 40 års intens dinosaurforskning, er, at den traditionelle opfattelse af dinosaurerne var forkert. De var ikke dorske, småt begavede monstre. De var fantastisk forskelligartede dyr. Nogle graciøse, tobenede, andre firbenede. Nogle ensvarme, nogle måske firklædte. Visse af dem levede i flok, og mange eller alle beskyttede de deres unger. De vandrede vidt omkring, med imponerende kløer og tænder, parat til kampen om bytte, eller pansrede med horn og pigge som forsvar mod kødæderne. Tyrannosaurus rex, Iguanodon, Brontosaurus, Deinonychus, Stegosaurus. Og med en længst døde og kun bevaret som fossile knogler, strejfer de stadig om i vor fantasis skove. og flere af deres slags venter stivnede i stenen på, at vore efterkommere skal finde dem og henrykkes over dem. Børn og voksne, forskere og lægfolk.
Okay, so the dinosaurs went extinct. Things like Allosaurus and all its giant kin died out. Is that a tragedy for everybody? Well, no. If you were small, you survived. And if you were small and furry and had a twitchy nose and beady eyes like this chap, you could evolve into a wonderful range of big mammal families. You could evolve into moose, you could evolve into aardvarks, into warthogs, into apes, into humans. So from an ancestor like this came people. Humankind owes its success story to the extinction of giant dinosaurs.